Here we go with density. Density has two parts, the mass and the volume. So we have already talked about how to calculate volume of different objects. And I'm going to talk a little bit about mass, and then I will tell you guys how to calculate density. First off, to take the mass of an object, you guys will be using a balance. And I have a picture of a balance right here. Make sure that the balance is on a flat surface and then click the on button. And once you click on, it will go to 0. Once it's on 0, then you can place the object on the balance and it will give you an accurate reading. As always, mass will be in grams in this class. I have an example that I'm going to use. It'll be a box, so that's why I have a box here. And let's just imagine I would like to take the mass of that box. So all I would do is place the box on the scale, and then it would give me a reading. And we're just going to pretend that that reading is 60 grams. So for my mass, it will be 60 grams. Now for volume, we've talked about a couple of formulas for volume. By the way, volume is just the amount of space that something takes up. And we have talked about measurement, and we have talked about water displacement. I don't know if I have told you this, guys, yet, but measurement will always be more accurate than water displacement. So you guys will be in charge of measuring. So for example, the volume of a cube or a block, you will always use length times width times height. And then for a cylinder, your volume formula will be pi times the radius squared times the height. And your label will always be centimeters cubed. So you guys will use a ruler, a metric ruler, which is in centimeters. And just like down here with the box, I have pretend measured this box to be 5 centimeters in length, 3 centimeters in width, and 4 centimeters in height. So I can plug that in. Since this is a box, I would use length times width times height, which would be 5 centimeters times 2 centimeters times 3 centimeters, and that equals 30 centimeters cubed. That would be my volume for this box. Okay, so then what if I wanted to take the density? Density equals mass over volume. So just so that way you can see those terms. Mass divided by volume. That is density. Mass divided by volume. Mass will always be in grams, and then volume, since we're using the more accurate measurement, it will always be in centimeters cubed. When I think of density, I like to think of a heart. It looks like a heart to me. If you connect the M and the V, it looks like a heart. So that's how I always remember that mass goes on top of volume. And so if I plug in what I've already figured out, I have figured out, remember I took the mass to be 60 grams, and I just figured out my volume to be 30 centimeters cubed. So if I plug that into my density formula, I end up getting 2 grams per centimeters cubed. Okay, so let's kind of apply density here. What if I cut this box in half? Well, if I cut it in half, then my mass will also be cut in half because it's going to weigh half as much as it did if I cut it in half. So it went from weighing 60 grams to now weighing 30 grams. And then of course my volume, since I've cut the size, the volume will also be half. It will take up half as much space as it used to. So my volume will go from 30 centimeters cubed to 15 centimeters cubed. So if I cut the box in half and I try to figure out the density again, I can plug in my mass for 30 grams divided by my volume of 15 centimeters cubed, and I still receive 2 grams per centimeters cubed. One thing that is really neat about density, it happens to be a physical property of materials. It's physical because, you know, there's no reaction, there's no color change or smoke. We're just taking measurements, but it's still a characteristic of an object, of the material. And in fact, with size and shape, density will never change. So it doesn't matter what size this box will be, because it is made of cardboard, the density will always remain the same. Okay, now obviously I made up these numbers, so this may not be the exact density of cardboard, but just know that density of an object will never change. It will always be the same as long as it's made of the same material. Last but certainly not least, when we talk about density, at least at first, we talked about, did things sink or did they float? I want to ask you guys the question, would this cardboard box sink or would it float in water? Here's how we can figure that out. So we already know that density is 2 grams per centimeters cubed, and that's, again, for the cardboard box. The density of water, you guys will have to memorize the density of water, which, don't worry, it is super easy. It's 1 gram per centimeter cubed. So the density of water here, 1 gram per centimeter cubed, compared to the density of our box is 2 grams per centimeters cubed. And hopefully you can figure out that 2 is much greater than 1. So with 2, my density of 2 being greater than my density of 1, that object will sink. Because if you remember, an object will sink if it has a greater density than the material or the liquid that you are placing it in. Since this cardboard box has a greater density than the water, that it will sink. If the object had a density that was less, a less density than the water, then it would float. So if I ever ask you, like, I don't know, say on a quiz or on the test, if I ask you if something sinks or floats, you're going to have to compare the densities and look to see if the density of that object is greater, it will sink, and if the density is less, it will float. So hopefully you guys can help memorize that, because it will definitely be on the test. All right, good luck in the lab today.